Now conformations of N-butane. So here I told you in the last video what are conformers or conformations. Here change in the spatial arrangement of the atoms around the carbon atoms due to the carbon-carbon rotation. Okay, carbon-carbon single bond rotation. Those are called as conformers or rotamers also. Rotamers and conformations. So here in the last video we have discussed the conformations of ethane. I told you the conformations will be represented in two ways, Newman projections and the Sahar's representation, like this. Here now we'll discuss in this video, we'll discuss what are the conformations. We'll discuss the conformations of butane and the stabilities. It is N-butane, no? CH3, CH2, CH2, CH3. Now this is your first carbon atom, second carbon atom, Newman projection. So first carbon atom represented with the dot. So here the groups. So here it is the CH3 groups and the remaining two hydrogens here H1 and H2, like this I have represented. And here it is the second carbon atom, and the second carbon atom methyl group exactly backside of the methyl group, and another carbon atom hydrogens here H3 and H4. So here what is the dihedral angle? Exactly these two methyl groups are exactly here the front carbon methyl group is exactly backside of the second carbon methyl group. So the dihedral angle between these two is 0. Theta is 0. Now here by keeping the front carbon fixed and you rotate the second carbon to here 60 degrees, 60 degrees, 60 degrees. So here to 60 degrees. 60 degrees we are rotating the second carbon atom. So here this is your first carbon atom, which is CH3, H1, H2. Now I'll clear this one. So CH3, H3, H4. Now what is the theta between these two, which is equal to, we have rotated to 60 degrees, no? 60 degrees. So here likewise in the case of the ethane, here front carbon fixed and the second carbon we have rotated to 60 degrees. And now you rotate again this to 60 degrees, second carbon, what you will get? This will come this side, this come this side, and this comes this side. So what will be your new conformer? Here it is CH3, H1, H2, and CH3, H3, H4. Now again you move this to back carbon to again 60 degrees. What? Here is your front carbon CH3, H1, H2, and the back carbon CH3, and here is your H4, and here is your H2. Okay, if you rotate and you can get another two conformers. So till you can rotate the back carbon till you get this one. Okay, now to explain the conformations of butane, till now it is sufficient for me. So here now if you look at the two groups here, what is the bond angle between these two? What is the dihedral angle between these two? It is 180 degrees. So now I told you in the conformations of ethane, if the dihedral angle theta is equal to 0, here there will be that conformation we call it as eclipsed conformation. Eclipsed conformation. And here it is, if the theta is equal to 60, there we call that as a staggered conformation. But here it is Gaussian. Why, ma'am? Because here in the ethane CH3, here we have all are here first front two carbon atoms groups are identical. If the two carbon atom groups are identical, then there will not be any Gaussian conformation. But here there are two different groups. Methyl groups are there, hydrogens are there. Okay, so here in the staggered, here it is the staggered conformation. Here it is the staggered conformation. The only conformation in which the staggered conformation is having dihedral angle is 60 is ethane. Okay, in ethane only the staggered form is with a dihedral angle 60. Otherwise the staggered form, or we call it as an anti-form, here in which the bond angle, in which the dihedral angle is 180 degrees. Here why no Gaussian form in the case of ethane? Because here it is having two carbon atoms are having same groups, means same means all are hydrogens. So there is no Gaussian. But here methyl group is there, hydrogen is there. So two methyl groups are at an angle of 60 degrees and here the two methyl groups are at an angle of 180 degrees. This conformation is the most stable conformation. Why? I'll tell you. Okay. So here this is the eclipsed form in which the dihedral angle is 0 and it is the Gaussian form in which the dihedral angle is 60 and this is the staggered form in which the dihedral angle is 180 degrees. Now I'll tell you first I'll write the stability order. Stability order. Staggered form or anti-form is more stable. After that Gaussian, then last eclipsed. Here I'll explain this one. Listen to me. Here two methyl groups, for example, here when the two methyl groups are spatially closer. So here is your this is your first carbon, second carbon and first carbon methyl group, second carbon methyl group. Blue one is the second carbon methyl group. This red one is the first carbon methyl group. So first carbon, second carbon. These are like this. So these are spatially closure. So here when they are two bulkier groups are here, this is in the case of this is true also in the case of ethane also. Why eclipsed form? Because high repulsions. I told you no high repulsions because they are spatially close. But here you compare hydrogens and methyl groups, here large bulkier groups when compared to hydrogens. When two large bulkier groups are spatially close to each other, there will be a van der Waals forces of repulsion exist between these two. Because of these high van der Waals forces of repulsions, here the energy will be increases and the stability will be less. But if you compare the eclipsed form and Gaussian form, in which here it is we are keeping the front carbon constant and here they are spatially far when compared to the eclipsed form. So here the van der Waals forces of repulsions are less when compared to the eclipsed form in the Gaussian form. So when compared to Gaussian and eclipsed, Gaussian is more stable because here the bond angle, dihedral angle also increased, no, because it has moved to for 60 degrees far from the front methyl group. This is the second carbon methyl group. I have rotated to 60 degrees. And again, look at this one. Here these two are completely spatially far apart like this. Okay, so the van der Waals forces of repulsions are eventually zero because anti-conformation. Okay, like this. So here, at a bond angle of 180 degrees, there will be no van der Waals forces of repulsion because they are spatially far apart each other. So because of the less van der Waals forces of repulsions, the staggered form is considered to be the most stable form in the butane, in the conformations of butane. Clear? So here I have told you one important point. The bond form means the dihedral angle is 180 degrees. But only in the case of ethane, the staggered form is with a dihedral angle of 60 degrees. Okay. Now, what is the most stable conformer of the butane? Here, staggered form is the most stable conformer because these two bulkier groups are spatially far apart. You observe 1, 2, 3. I'll clear this one. Okay, 1, 2, 3. You observe. This is the eclipsed form, Gauche form, and the staggered form or the anti-form, and it is the stability order. Okay. This is the stability order, and if you want to write the energy of the eclipsed form is greater than Gauche than staggered. This is the energy order. Okay, I think you got one clear idea what are the staggered form and what are the dihedral angles in the staggered form and what is the Gauche form and what is the eclipsed form. Okay.